Hello all and welcome back. In this video, we are going to cover Amazon DynamoDB Throughput capacity followed by a quick demo. Amazon DynamoDB Throughput capacity depends on the read-write capacity modes for processing reads and writes on the tables. DynamoDB supports two types of read-write capacity modes: provisioned and on-demand. Provision mode requires you to specify the numbers of reads and writes per second as required by the application. Provisioned throughput is the maximum amount of capacity that an application can consume from a table or index. If the provisioned throughput capacity on a table or index is exceeded, it will lead to request throttling. Provisioned mode provides read capacity and write capacity units. A read capacity unit determines the total number of read capacity required. It depends on the item size and the consistent read model, which includes eventual, strong, and transactional consistency. Write capacity unit determines the total number of write capacity units required, which depends on the item size and the write model, which can be standard or transactional. Local secondary indexes consume the base table's capacity units, while for the global secondary indexes, you need to configure provisioned capacity separate from the base table. Provisioned capacity mode might be best for use cases where you have predictable application traffic. You run application whose traffic is consistent or ramps gradually and can forecast capacity requirements to control costs. Provisioned mode examples. I would cover a few examples demonstrating the provisioned throughput capacity calculations in this demo, so stay tuned. On-demand mode. On-demand mode provides a flexible billing option capable of serving thousands of requests per second without the need of capacity planning. You don't need to specify the expected read and write throughput. You are charged only for the reads and writes that the application performs on the tables in terms of read request units and write request units. It basically offers a pay-per-request pricing for the read and write requests so that you pay only for what you use. DynamoDB adapts rapidly to accommodate the changing load. However, on-demand mode does not support reserved capacity. On-demand capacity mode might be best for use cases where you create new tables with unknown workloads, have unpredictable application traffic, and prefer the ease of paying for only what you use. In this demo, we are going to cover DynamoDB throughput capacity and also demonstrate provisioned capacity calculations. Open the DynamoDB console. We already have a DynamoDB table movies created with some data added to it. Navigate to the additional settings and we can see the read and write capacity. The table currently has the settings configured for provisioned capacity. Now the provisioned mode requires you to specify the number of reads and writes per second as required by the application, and it is the maximum amount of capacity that an application can consume from a table or an index. The read and the write capacity is configured for 5 capacity units with auto scaling turned off. We have covered auto scaling in greater detail in another demo. Let's edit the capacity mode. And you would be provided an option to switch between on-demand and provisioned capacity modes. You can select the on-demand capacity mode, which provides a flexible billing option capable of serving thousands of requests per second without any capacity planning or specifying expected read and write throughput. We'll revert it back to provisioned throughput capacity for now. Let's cover a couple of examples demonstrating DynamoDB provisioned capacity calculations. The provisioned mode provides read capacity units and write capacity units. The read capacity units denote the total number of read capacity units required to read an item, and it depends on the item size and the read consistency model. An eventually consistent read request of an item up to 4 KB requires only a half read request unit. So basically you can perform an eventual consistent read of up to 8 KB with one read request unit. Now an eventual consistent read might not reflect the results of a recently completed write. A strongly consistent read request of an item of up to 4 KB requires one read request unit. So basically there is a one-to-one mapping, one read request unit for one strongly consistent read of up to 4 KB. And it is 2x the cost of eventual consistent read. A strongly consistent read returns a result that reflects all writes that received a successful response prior to the read. A transactional read request of an item up to 4 KB requires 2 read request units. That is, it is 2x as costly as a strongly consistent read and 4x as compared to an eventually consistent read. For reading, the item size is always rounded off to 4 KB equivalents. So even if you have an item size of 1 KB or 3 KB, it will be rounded off to 4 KB for calculations. Write capacity units. Write capacity units denote the total number of write capacity units required. And it also depends on the item size and the write model. A standard write request per second for an item of up to 1 KB requires one write capacity unit. And a transactional write request of an item of up to 1 KB requires 2 write capacity units. So it's 2x as costly as a standard write. The item size is rounded off to 1 KB equivalents. Let's go through a quick example. We will calculate the read and write capacity units required for reading and writing an item with 15 KB of size. For the read throughput, if we divide 15 KB by 4, it would give us 3.5, and rounding it off would give us the count 4. With eventual consistent read, we would only require 2 read capacity units to read this data, as one RCU can perform 2 eventual consistent reads of 4 KB each. With strong consistent read, we would require 4 RCU, as one RCU can perform one strong consistent read of 4 KB each. And with transactional read, we would require 8 RCU, as we need 2 RCUs to perform one transactional read of 4 KB each. So if you see, transactional is twice as expensive as strong consistent read, and the strong consistent read is twice as expensive as an eventual consistent read. For the write throughput, if we divide 15 KB by 1 KB, it would give us 15. With standard consistent read, we would require 15 write capacity units, as one write capacity unit can perform one standard write of 1 KB each. With a transactional write, we would require 30 write capacity units, as 2 write capacity units are required to perform one transactional write of 1 KB each. We can check the same through a capacity calculator as well. Let's expand the capacity calculator. Enter 15 KB for the average item size. And you can see for eventual consistent read, it would need 2 RCUs. If we change the read consistency to strong, we would need 4 RCUs. And for transactional read consistency, we would need 8 RCUs. For standard write consistency, it would need 15 WCUs. And for transactional write consistency, it would need the double, that is 30 WCUs. The cost has also increased with the item size and the change in consistency model. Let's go through another calculation example. We will calculate the capacity supported for a DynamoDB table with a configured provisioned capacity of 10 RCUs and 10 WCUs. For read capacity, with eventual consistency, we can read 80 KB of data per second. With strong consistency, we can read 40 KB of data per second, that is half of eventual. And with transactional consistency, we can read 20 KB of data, that is the half of strong consistency. For write capacity, with standard consistency, we can write 10 KB of data per second. And with transactional consistency, we can write 5 KB of data per second, which is the half of the standard. DynamoDB distributes the data across partitions, and the provisioned throughput capacity is distributed equally across these partitions, and these are physical partitions and not the logical partitions based on the primary key. Also, the key point to note is each partition on DynamoDB table is subject to a hard limit of 1000 write capacity units and 3000 read capacity units. DynamoDB would throttle the requests when data access is imbalanced. That is, a hot partition can receive a higher volume of read and write traffic compared to other partitions, leading to throttling errors on that partition. If the workload is unevenly distributed across partitions, or if the workload relies on short periods of time with high usage, the table can still be throttled. Also, if the write throughput capacity on a global secondary index is not sufficient, it would lead to throttling on the GSI, and this would affect the base table as well. To avoid and handle throttling issues, you can distribute the read and write operations as evenly as possible across your table. A hot partition will always degrade the overall performance of your table. Implement a caching solution either using DynamoDB Accelerator (DAX) or even Elastic Cache. Or you can implement error retries with exponential backoff. Exponential backoff can improve an application's reliability by progressively longer wait between the retries. And if you are using an AWS SDK, this logic is built in. DynamoDB burst capacity. DynamoDB provides some flexibility in the per partition throughput provisioning by providing burst capacity. If the partition's throughput is not fully used, DynamoDB reserves a portion of that unused capacity for later bursts of throughput to handle usage spikes. DynamoDB currently retains up to 5 minutes of unused read and write capacity. These extra capacity units can be consumed quite quickly during an occasional burst of read or write activity. And DynamoDB can also consume this burst capacity for background maintenance and other tasks without prior notice. DynamoDB adaptive capacity. DynamoDB adaptive capacity is a feature that enables DynamoDB to run imbalanced workloads indefinitely. Adaptive capacity enables the application to continue read and write to hot partitions without being throttled, provided that traffic does not exceed the table's total provisioned capacity or the partition's maximum capacity, which is 1000 WCUs and 3000 RCUs. Adaptive capacity also helps minimizing throttling due to throughput exceptions. It also helps reduce costs by enabling the provisioning of only the needed throughput capacity. It also helps reduce costs by enabling the provisioning of only the needed throughput capacity. Adaptive capacity is enabled automatically for every DynamoDB table at no additional cost. So that's it for a quick overview on DynamoDB throughput capacity. I hope you liked the demo. Thank you all. Alright, that was it. Thank you for watching. You can check out my website and connect me on LinkedIn and Twitter. If you enjoyed this video, please give it a thumbs up. For any feedback, please leave a comment down below. To see more videos like this in the future, hit the subscribe button. Thank you.